This is section 2.6, transformation of graphs. And before we begin, we're going to go through some basic functions. And some of these you will be able to recognize once we work a few problems with them. You have seen a linear function before. It is the graph of a line. It's f of x equals mx plus b. M is your slope. B is the y-intercept. A constant function, y is always a constant. And in this case, in this example, we have y is always 2. We have the identity function, y is equal to x, and that is every x and y coordinate are the same. So the point 2, 2 is on the graph. The point negative 1, 2, 3, 4, negative 4 is on the graph, and so forth. The absolute value function, y is equal to the absolute value of x. So no matter what x value is input into the function, the y value is the positive part only. So you would have this point 2, 2 on the graph, and you would have negative 3, 3 on the graph. So the y value is always positive. And we will be able to put these in our calculator and view them. Here is our quadratic function. Y is equal to x squared. When x is 2, y is 4. So 2, 4 is on this graph because when you square 2, y is equal to 4. So placing these in our calculator is quite simple. So you just want to press the y equal button, and I'll actually show you how to put, let's say, the quadratic function in. So that's y equals x, and then you can press this x squared button here. And then you just have to, I use Zoom 6 so that it gives me a 10 by 10 window. On this calculator, I can pull the screen down a little bit. This is an interesting one, this absolute value function here. I will show you how to input that. So go back to y equals, press clear, and now you're going to press the math button, and then you're going to arrow over to numerical. And as you can see, if you look at number 1, that's the absolute value function, and I'll put an x in there. So once that is input, you can just press graph, and there you have it. Once you are in these graphs, you can press trace, and you can just enter a value, and it will give you the y value for that. So I just said when x is 2, and it gave me y is 2. I will type in a negative 3 and press enter, and a positive 3. So that is just the points and everything that I went through there. And you can do that with any of these functions. Okay, and going on, we have the cube function, square root function, cube root function, and the reciprocal function. Okay, so now with these parent functions, sometimes I'll call these the parent functions, but they are also the basic functions. So now we will transform these. So we will be applying both vertical and horizontal shifts to these graphs. So for a vertical shift, as you can see, we will add and subtract constants on the outside of f of x. And that will shift the graph either up or down that many units. But if you notice now here, we are adding and subtracting a constant within f of x. Here we were adding and subtracting outside of f of x. And now this will give us a shift to the right and to the left. Be very careful here, because when you have a minus a positive constant, so like a -5, you are going to be moving to the right. It's backwards of what you think. And when you have a positive constant added inside, then inside the function, then you will shift to the left. Let's go ahead and try a couple. Look at the difference here. Here we are on the outside, and here we are on the inside. So this is on the outside of the function, and this is on the inside. We're adding 2. So what is this parent function or this basic function? The original function was y is equal to the square root of x. And you could name another function. I could have said h of x. But here is our parent function there. Now we're going to plug in these values, and then we're going to talk about how this graph shifts, okay? So let's go ahead and do that. I'm just going to go ahead and give some basic values. So we have 0, 1, 2, 3, 4 on our graph. So we're going to take the square root of all of those numbers to get the y value, because that's what that function does. Now we're going to add 2 on the outside of the function, and let's see, that means we're going to add 2 to y. So that would be 2, 3, root 2 plus 2. That's about 3.4. Root 3 plus 2, that's about 3.7. And 4, that's 2 plus 2. Now we're going to go on the inside of the function. So as you can see, before we take the square root, we're going to add 2, okay? So if we add 0, if this is 0, then we're just going to have the square root of 2, and that's about 1.4. Now we're going to add 1, so that's the square root of 3. And then we have 2. We have root 5. And we have root 6. Now, what happened here for each of these graphs? If this is g of x, which is root x plus 2, and here is f of x, which is root x plus 2, what happens? Here we are going to shift the graph up 2, and here we are going to the left 2. So let me go ahead and just graph the parent function, root x. It looks something like this. Whoops. And those are just the points that I had graphed before. Let's see if this will actually, it didn't do that. Sometimes this program will actually create a nice curve for me, and maybe I'm just trying too hard, but there we go. There's root x. This is the parent function, and then I'll just copy that. Or I could just move it over there. And then we will have, we might have another graph. Okay. So now let's go ahead and sketch these points on g of x equals root x plus 2. So the entire graph is going to be shifted up 2 units. So this will go up 2 units, and this point will be shifted up 2 units, and that's what the graph will look like. And you can also see these points too. 1, 3 is right there, and then 2, 4. I wonder if I did that original one. Excuse me. It should be 4, 2. So that's correct. And then that one's correct, yes. Okay, so now let's go ahead and look at this one. Here we're going to the left 2 for each point. And it looks a little something like that. Not really like that. Okay, so there we went left 2 and up 2. And we can also plot those points that we came up with over here. Okay, let's try another one. What do you notice? Here, we're on the outside of the parent function, y equals the square root of x squared. And that would be, let's put some points on there. 0, 0, the square root of 0 is 0. Excuse me, 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. That's a little bit off of our graph that we have, but that's okay. Let's go ahead and plot those first this time, the parent function. See if I can do a better job at that. 1, 1, 2, 4. And those will be the same over here. Okay, I'll draw very good. And now I'll just copy that so that we have the shift There we go. Okay, so let's go ahead and plug these points in first and see what we have. This time, the -2 is on the outside. So here, we're going to actually be going down 2. And then here, we're going to be going to the right 2. Okay, but let's go ahead and get these points first. So whatever this y value is, we're going to subtract 2 from that. So we're going to have -2, -1, 2, 7, 14. Now this time, when we are going to subtract 2 on the inside of the function, we will be taking 2 from this x value, and then we're going to square it. So that would be 4, 1, 0, 1, 4. And you can pause the video a minute and see if that helps. And you can confirm that. So here we have h of x is equal to x squared minus 2. That took us down 2. And then we have k of x is equal to x minus 2 all squared. And that will shift the graph to the right. Let's see how it looks. -2, 4. Whoops, that's not right. 0, -2. 1, -1. 4, 2. Excuse me, 2, 4. 2, 2. I don't know where I got 2, 4. 3, 7. Okay. And we don't have 4, 14, but we could also have the other side of the graph showing those symmetrical points. And you can see how that graph comes around like that. So we definitely shifted the graph down 2. Let's plot these next points. 0, 4. 1, 1. 2, 0. 3, 1. and 4, 4. So this one is really obvious how it was shifted to the right 2. Okay, how about this? We have a combination of transformations. So this here, this +1 means we are going to go to the left 1. One unit. And then since this -4 is on the outside, we're going to be going down 4. So what we could do is we could just write a few of these points from that original graph and then make those shifts. So the parent function is f of x, or y equals x squared. And those points would be, we have x and y points. And we can give some negative ones. I didn't in the above examples, but it might be nice to have some. So those on the graph looks something like this. Okay, so that's the parent function, f of x equals x squared. And now with each one of these points, we're going to go to the left 1 and then down 4. So left 1 and then down 4. And then left 1 and down 4. And so forth. And you can see that right here. You can see that symmetry. And that is just brought around like that. That last line I didn't do a very good job. And this is supposed to be smooth, not pointy. So this is actually supposed to come around here and be a little bit more round than pointy. Okay? Okay, let's keep going. Look at this next one. Our parent function is the absolute value graph. And that's f of x equals the absolute value of x. We can just give a few points. And that's just the absolute value of those numbers. And as you can see, the absolute value graph is always the shape of a V. And we can bring that through here. Just like that. And that is y equals the absolute value of x. And you know what? I should have labeled this down here as z of x. And that's where we went left 1 and then down 4. Okay, so back to this graph, you can see we are on the inside here. So we're going to go to the right 2, and we're on the outside of the function here. So we're going to shift up 3. So taking every one of these points, and actually you can do that with a graph. So this could be p of x. And if we're going to the right 2, we will add 2 to all of those x coordinates. And if we're going to go up 3, we could just add 3 to these y coordinates. And let's go ahead and graph that. So we have 0, 5, 1, 4, 2, 3, 3, 4, and 4, 5. So as you can see, there is P of X. And that shifted to the right 2 and then up 3. Now we are going to do a little shrinking and stretching. So all we did here previously was we shifted vertically and horizontally, but we never compressed the graph or stretched the graph. And so let's take a look at what this means. So to apply vertical and horizontal shrinking and stretching, basically, if you multiply a function by a constant greater than 1 on the outside, you will stretch the graph vertically by a factor of that value. If you have a fraction, so this is when you have a fraction, a number between 0 and 1, and you multiply that on the outside, you will actually shrink the graph vertically, and you can also call it compress. Okay? Now, what happens when you have a horizontal shrink or stretch? It is the opposite of what you would think. Here, we have a number, a constant greater than 1, and now we're going to shrink horizontally. And shrinking horizontally is very similar to stretching vertically. And then here we go, another fraction. If we multiply the inside of that function, multiply that x by a fraction, we will then stretch horizontally, okay? So let's see what we have here. We've got a little example here. We have two functions, f and g. And let's go ahead and see what happens. Again, we have a parent function of y equals x squared. We can go ahead and just get that parent function 1, 2, 3, 4 on the graph. And 3, 9 would be on there, but I think the graph just goes to 8. But I can go ahead and put those points on there. So it looks something like that, y equals x squared, okay? And it really, I'm really struggling with this down here because the graph is really not supposed to have that pointy look down there. Really trying hard to get that moved over. But let me just try one more time. There we go. And you'll be able to see when you put these in your calculator that they're very smooth graphs. Okay, so this is the parent function y equals x squared. Now, as you can see, we have a fraction on the outside of the function being multiplied. So that is this case right here. Okay, and so what does that say? We're going to shrink vertically by a factor of a, by a factor of 1/4. Okay, so let's go ahead and just use our coordinates and see what happens. So on the parent function, when we square 0, square 1, square 9. Okay, and now we're going to take 1/4 of these numbers. And so as you can see, that's definitely going to be a vertical shrink because these y values have shrunk. If you look at the difference between this value and this value. Okay, now what happens, let's go ahead and fill these values in for our parent function. And now we're going to take those y values and we are going to multiply them by 4. So you can see that the y values from here to here by a factor of 4. And that is because that 4 was on the outside of the, multiplied by a number greater than 1. So that would be this case. And that is a vertical stretch. So we could put a few of those points on here. It's a little difficult to do that, but let's just go ahead and try. We will put the 1/4 x squared first. So we have 0, 0, 1, 1/4, 2, 1, 3, and then it's a little bigger than 2, and then 4, 4. So you can really see that shrink, that compression. And then we could always put a few of those points over here because it's going to be symmetric. And you can kind of see that. And this is f of x. And now, so that's definitely a vertical compression or a vertical shrink. And then now, I'll change colors here to make it a little easier. Let's go ahead and plot these next points. We have 0, 0, 1, 4, and then 4, 16. So we're going to be way, way up. So we will just plot these, and you can clearly see that this is a vertical stretch. So this is g of x. And you can actually put those in a calculator and see all 3 graphs at one time. Okay, looking at number 6. We are now on the inside of the function. As you can see here, we were multiplying by the outside of the function here. But now we're going to be on the inside of the function multiplying x by a constant. Here the constant is greater than 1. Here this constant is a fraction. So as you can see, we're going to have both of these cases. So since our constant is greater than 1, we're going to have a horizontal shrink here. And since we have that fraction on the inside, we're going to have a horizontal stretch. And we could go ahead and write this here. And this was a vertical shrink. And that is because that is a fraction. And then we have a vertical stretch. Okay, so let's do the same thing here. Let's go ahead and note that our parent function is the square root function. So we have y equals root x. And so if we take the square root of these numbers, this is what we get. It's not that great because these are decimals. We should have used a bigger graph. And now we are going to multiply x by 5 and then take the square root of that. And so that would be the square root of 5. Now here we're going to have the square root of 25. So that'll be 5, square root of 30, square root of 35. But now over here, we're going to take a fifth of that y value and then take a square root. Whoops. Okay, and then plotting these, I'll do my best here. Let's go ahead and get the parent function on there. So the square root of 1 is 1, 2, 3, 4. The square root of 4 is 2. Square root of 9 is 3. So here is that beautiful root function. This is y equals the square root of x. So now if we plotted some of these other points, and we could do it in the calculator and find some values, you will have a point here, 1, 2, 3, 4, 5, about 5, we could just put that on there, 5, 1. So this is s of x, and then we could pick this point 5, 5, and this is r of x. So as you can see, we pulled this horizontally, and then we shrunk r of x. We shrunk the parent function horizontally and gave us r of x. Okay, so now we're actually going to shift points. And they're asking us to use this graph of f of x. So this is given as f of x. And they want us to then create y equals f of 4x. So what do you notice first of all? Do you notice that we have a constant greater than 1 and it's on the inside of the function? So as you can remember, it's going to be a horizontal shrink, but let's go ahead and find that. As you can see, we have a constant greater than 1 on the inside of the function, and we will have a horizontal shrinking. But if you use points, you really don't even have to memorize that. So let's write what points we have on this graph. Let's just list them. So the first one I'm seeing is -3, -1. That's that point, and so forth. -1, 1. And what is that? 4, -3, and then 6, 3. Now let's transform these. And how are we going to do that? Well, we have 4 on the inside. So that means we are going to take every x value and divide it by 4, okay? Since we have this horizontal shrinking. So we are going to okay, so now we have a -3/4 -1. And then, because remember, we're making these x values smaller by a factor of 4. And 6 divided by 4 is 3/2 and 3. So if we come over here and we graph that, so we have -3/4 -1, -1/4 1, 1 -3, and then 1.5 3. And as you can see now, we have the graph that looks like that. So you can see this horizontal shrinking. Okay, let's get to reflections. And reflections are quite simple. You can see a negative sign placed on the outside of the function and a negative placed on the inside of the function. So what happens if we are taking the opposite of our original function? Think about that. If our y value was here and now we're taking the opposite of it, we're going to end up down here and reflect across the x-axis, okay? Likewise, if you had a point here and you were then taking the opposite of that x value, you are going to reflect across the y-axis if the value is in there. So let's give a few of these a try. In number 8, they tell us that the graph is given of f of x. So this is f of x. And now what are we going to do? We are on the outside, so we are going to reflect across the x-axis. And here on the inside, we are going to reflect the graph across the y-axis. Okay, so let's go ahead and take every point on f of x and move it across the x-axis. So this is going to stay the same at the origin. This point will go there, and what is that point? That is 3, 3. So that is 3, and now we'll have negative 3. And then that's 4, 1, and we'll have 4, negative 1. So we can draw our graph like that, and then like that. So that reflects across the x-axis. Now, let's go ahead and take all of these across the y-axis. So this point now goes over here. This point now goes, what is that? 1, 2, 3, 3. So it's going to go all the way here. Erase that. And then this last point, which is 4, 1, is now going to be negative 4, 1. And so that graph just looks like this. So in summary, this is a very, very nice table. I do want you to try to keep this simple. I want you to use your calculator if you're in doubt. And just go ahead and read through these. We had our vertical and horizontal translations. Those were simple shifts, simply shifts. Then we had some stretching and shrinking, both horizontally and vertically. And then we had a reflection. Let's try to put all of this together, but let's remember the order. The very first thing you're going to look at is your horizontal shifts. Then you're going to go to your horizontal and vertical stretch and shrinks. Then you're going to do your reflections. And the very last thing you'll do is your vertical shift. Okay? So you could think of it as your horizontal shift, and then you're going to do your horizontal and vertical stretches and shrinking. So stretches and shrinking, and it's both of them. And then you're going to do your reflections, and the last thing you're going to do is your vertical shifts. Okay? And remember, that's going to be on the outside of the function, when a constant is added to the outside of the function. So let's take a look at number 9. We have a parent function, the absolute value of x, and you can see it right here. Okay, and if we want to shift the graph to the left 1 unit, do you see how we add 1 inside the function? So if we have a vertical stretch, we are on the if we have a vertical stretch, we have this 2 on the outside, and it's greater than 1. So that's not a fraction, so that's why it's a vertical stretch. And then we will go down 3. And that's the last thing we look at on there, and you can see that over to the right. So let's give number 10 a try, and then we will just wrap this up. And actually, number 10 is shown below here. And here is just the graph of the parent function that you can work with. And you can mark up. There's 1, 1, 4, 2, and so forth. Okay? And we could actually put that over here if you'd like. And that's that parent function. Okay, so now let's work through each one of these shifts. Remember, the very first thing we're going to do is we're going to work on that inside, and that gives us our horizontal or our vertical. And as you can see, this is a bit of a mess when it looks like this. However, I'm going to have you rewrite this, and that's going to be negative 1/2 times the square root of the opposite of x plus 3. So I just switched places here, okay? So let's go through each item that we have. This first is this horizontal shift. And then here is a horizontal reflection. And then, and I'll explain this in a minute. Let me go ahead and explain this. That's not very good. Which is equal to taking this negative out and writing it like that. Now that I think will help you. So here is a horizontal shift to the right, and I'll just write right 3. That's horizontal. And then this is a reflection across the y-axis. Remember, we're taking the opposite of those x values. And here we have a vertical shrink, because remember, that's a fraction on the outside. And then there's that negative on the outside. So that is a reflection across the x-axis. Okay, so when we do these in order, if you took each one of those points one at a time, you would come up with, and you could do that with each one of these points, but the expectation is not going to be there for these. You will just have your calculator there for these more complicated ones, and you can just go ahead and kind of get them on the graph. So this is going to look something like this. And I show you that because we've gone to the right 3. I'll kind of walk through this. The right 3. And then remember, we go ahead and take care of our shrinking next, as you can see. And then we'll do the reflections, and we do not have a vertical shift. So now we'll do this shrinking, which then instead of like this, it became shrinking vertically. Then we take care of our reflections. So we went here, and then we went down here. Whoops. So we went, that's right. So we flipped vertically, and then we flipped reflected horizontally. And that's how we arrived at that graph. And we could put these in the calculator also. I'll just show you that before. Where you can put these both in the calculator and take a look at them. And so here we have, let's clear that, whoops. And we have opposite of 1/2. And then we have the square root of 3 minus x. And then we have, oops, I should have put the parent function in there. And so the blue function will be our new function, and then the red function will be our original root function. so you can see the graphs there. And our window was a little bit moved that way, I guess. And then you can just move these points around. Okay, well that concludes this section.